When electrical loads are unbalanced, it can influence the amount on an electric bill, though the relationship is not always straightforward and depends on several factors related to the electrical power system and how the utility company meters the energy consumption. To understand the impact of unbalanced loads, firstly, consider what balanced and unbalanced loads mean in electrical systems, especially within three-phase systems which are common in industrial and commercial settings. Secondly, examine how electrical meters measure energy usage, which may or may not accurately reflect imbalances. Thirdly, recognize the potential effects of imbalances on electrical equipment and the power distribution system. In a balanced three-phase system, the loads on each of the three phases are equal or nearly equal. This means that each phase carries the same amount of current, and the voltage between each phase is also equal. This balanced condition is ideal because it maximizes efficiency and minimizes stress on electrical equipment. In contrast, an unbalanced system has significantly different loads on each phase. This can occur due to an uneven distribution of single-phase loads across the three phases, equipment malfunctions, or variations in load usage. For example, in a commercial building, if one phase powers a large number of air conditioning units while the other phases serve lighting and general outlets, an imbalance may arise. The impact of unbalanced loads on an electric bill depends largely on the type of metering used by the utility company. Traditional electromechanical meters measure the total power consumed without differentiating between phases or accounting for imbalances. In this case, the meter measures the total kilowatt-hours consumed, regardless of how evenly the load is distributed across the phases. However, many modern digital or smart meters are capable of measuring power consumption on each phase individually. Some of these meters can also detect and record parameters such as voltage and current imbalance, power factor, and reactive power. If the utility company uses such advanced metering and charges based on parameters beyond just kilowatt-hours, unbalanced loads can potentially increase the bill. One reason unbalanced loads may lead to higher costs is related to increased current in the neutral conductor. In a balanced three-phase system, the currents in the neutral conductor ideally cancel each other out, resulting in minimal current flow. However, in an unbalanced system, the neutral conductor carries the unbalanced current, which can lead to increased losses in the distribution system and potentially higher energy consumption. The additional current in the neutral conductor also generates heat, which represents wasted energy. Some utility companies may factor in these losses when calculating the bill, particularly for large commercial or industrial customers. Another factor to consider is the impact of unbalanced loads on the power factor. Power factor is a measure of how effectively electrical power is being used. A power factor of 1 indicates perfect efficiency, where all the supply power is used to perform work. A lower power factor means that a portion of the supply power is not being used effectively and is instead circulating in the system as reactive power. Unbalanced loads can lead to a decreased power factor, which means that the utility company must supply more apparent power measured in kilovolt amperes or kvolt amps to deliver the same amount of real power measured in kilowatts. Some utility companies charge customers based on their power factor, either through a direct penalty or by increasing the demand charge for customers with low power factors. Therefore, if unbalanced loads reduce the power factor, it could lead to higher electricity costs. The effects of unbalanced loads extend beyond just the electric bill. They can also negatively impact electrical equipment and the power distribution system. Firstly, unbalanced voltages can cause overheating and premature failure of three-phase motors. Motors are designed to operate with balanced voltages on each phase, and significant voltage imbalances can lead to increased current draw in one or more phases, resulting in overheating and reduced lifespan. Secondly, unbalanced loads can cause transformers to overheat. Transformers are designed to efficiently transfer power between voltage levels, but imbalances can lead to uneven loading and increased losses, resulting in overheating and potential damage. Thirdly, unbalanced loads can lead to voltage drops in the distribution system. Uneven current distribution can cause voltage drops in certain phases, which can affect the performance of sensitive electronic equipment and lighting systems. To mitigate the impact of unbalanced loads and potentially reduce electricity costs, several strategies can be employed. Firstly, load balancing involves redistributing loads across the three phases to achieve a more balanced system. This can be done by carefully planning the distribution of circuits and equipment within a building or facility. Secondly, using power factor correction equipment can improve the power factor and reduce the amount of reactive power circulating in the system. This equipment typically consists of capacitors that compensate for the inductive loads in the system. Thirdly, regular monitoring and maintenance of the electrical system can help identify and address imbalances before they become a major problem. This includes checking voltage and current levels on each phase, inspecting equipment for signs of overheating or damage, and performing regular maintenance on transformers and motors. In summary, whether unbalanced loads cost more on an electric bill depends on the metering practices of the utility company and the potential impact on factors such as neutral current, power factor, and equipment efficiency. While traditional meters may not directly reflect imbalances, modern smart meters and utility billing practices can lead to increased costs if imbalances are significant. Addressing imbalances through load balancing, power factor correction, and regular maintenance can help improve efficiency and potentially reduce electricity expenses. It's always a good idea to consult with a qualified electrician or energy consultant to assess the specific situation and determine the best course of action for managing unbalanced loads.